Good evening friends. Today we are going to discuss about the disjoint sets in data structure, right? So here we will discuss about the disjoint set operations, union and find algorithm, and what is the applications of disjoint sets, that is to detect a cycle, and this can be represented in two ways. One is graphical representation, another one is your array representation. First of all, I would like to say what is a disjoint set. So a disjoint set is a set in which, or we can say two sets can be said to be disjoint if suppose S1 union S1 intersection S2 will be phi. Then we can say that set 1 will be disjoint with set 2. Suppose here in my figure 1, suppose there are 4 elements 1, 2, 3, 4 and another figure that is 5, 6, 7, 8. Here we can say if this is suppose S1 my set 1 and this is suppose S2 my set 2. In this case these two sets are disjoints. So now the question is, what are the operations that we normally used to do in case of disjoint sets? That is, one is your find, another one is your union algorithm. Find means suppose I am telling you we are considering about suppose 1 and 2 edges. So whenever we will think that one edge 1 and 2, then if you will think that find 1 is in set 1 and find 2 is in set 2. So that is why both are in the same set. So these two are not disjoint. So if you will think about 3 and 4. So 3 is also available in set 1. 4 is also available in set 1. So this is also not disjoint. So if you will consider about 2 and 6, then 2 is available in set 1 and 6 is available in set 2. So these are disjoints. Now the question is, when we will operate these two algorithms, find and union algorithms. So actually we should have to check if the element is in different set, then we have to go for union operations. Suppose here we will include one edge from 4 to 8. Then what will be happen? Then this will be a single set and that set will be 1, 2, 3, 4, 5, 6, 7, 8. And this will be a universal set. And in this set all the elements are connected. So all the elements are not disjoints, all are connected, right? So in these cases we have included this 4 and 8 after going for union operations. Now we will check how this disjoint set operations are represented in two ways. One is your graphical representation, another one is your array representation. And whenever we will go for a graphical representation, we have to detect the cycle. Whenever we will go for the array representation, we have to detect the cycle. Now let us go for the representation of this. Suppose our universal set is this. You can think about this figure I am deleting. You can think about, suppose I have 8 elements, 8 nodes, 1, 2, 3, 4, 5, 6, 7, 8. Consider this figure. Here edge 1 I have considered 1 to 2, edge 2 is 3 to 4. Like this I have maintained it. So whenever we will go for the graphical representation, what we will do? How we will detect the cycle? The first thing is we have to go for one by one edges. Suppose you have considered edge 1, E1. What you have considered? E1 is your 1 and 2. Here you are not writing this because we are discussing about the graph. We are not discussing about mathematical union intersection operations. So that is why what you should have to do, you should have to represent it in the form of a graph. So here 1 and 2, if you will consider individually, both are disjoints. So if you will consider 1 and 2 edges, that means they are in a single set. So what you have to do? Now you have to union it and make a tree, and you can make like 1 will be the parent and 2 will be the child. In some of the book you can 2 is the parent, 1 of the child, no problem at all. So now suppose second case you will go for the E2. E2 is your 3 and 4. So 3 and 4 if you will consider these two, then what will be happen? You can consider 3 will be another and 4 is here, because these two are also separate. So now you consider the third edge E3. Where is E3? E3 is 5 and 6. So 5 and 6 you can also represent in the form of a graph, that is 5 will be your parent and 6 will be your child. Now after 5 and 6 you can go for 7 and 8. So 7 and 8 can be represented as E4, that will be 7, 8. Now till now we didn't get a cycle. Why? Because all are independent and all are disjoints. Now we will go through one by one, including, this is our graph, we will include all the edges one by one. So now you tell me what edges we have included. E1 we have included, this edge we have included, E2 we have included, this also we have included, E3 also we have, E4 we have included. Now go for E5. So 2 and 4. Suppose we will go for E5, that edges are 2 and 4. Now we will go for the find algorithm. Here I have written the find algorithm. Where is 2 available? So 2 is available in this. Where is 4 available? 4 is available in this. So we should have to go for a union operation. Here I have written the union operation. If U and V, you should have to find the U and find the V. If U is not equal to V, if here 2 parent is 1 and 4 parent is 3, both are unequal. So parent of V is equal to U. So what you have to do? Union operation. You have to do one parent will be the parent of another. So that means 1 and 2, and here you can add 3 and 4. This is our E5 after including E5. So now you delete these two, right? After that what we will do? We have included our 5th edge. Now we will include our 6th edge. 6th edge is our 2 to 5. So you go for E6. E6, that is 2 and 5. Now you check find algorithm. Where is 2 available? 2 is available in E5, this set. This is the whole set. Who is your parent? Now 1. Then 5 is available in this set. And who is his parent? Itself. So what you have to do? Now you have to go for, these are two disjoint sets, so you have to go for union operation. Union operation is saying that you have to find out U and V. So whenever you will find out U, you will get the parent is 1, and whenever you will find out the parent of this, you will get the 5. So what you have to do? Now if U is not equal to V, here U is not equal to V. Why? Because this is an independent set and this is an independent set. We have to make one as parent of another. So what you have to do? This is somewhat is the rank of this graph is more. So that is why this will be the one will be the parent of this. So what you have to do? Now the resultant will be like this: 1, 2, 3, 4, and here you can add 5 and 6. So now after adding this, remove this. This is your E6 after adding this. This is your result. Now you can go for E7. What is E7? Now E7 is your, now E7 is your this edge 1 and 3. So go for 1 and 3. Now you tell me 1 is available in which set? This set. Who is your parent? Itself. 3 is available in which set? Same set. Who is the parent? Now 1. So both are available in the same set. I told you that if both are available in the same set, then you can say that there is a cycle exists. So definitely if you will include this edge, obviously the cycle will exist. So that is why we should have to avoid, in case of detecting the cycle, like two algorithms are used to find out the minimum spanning tree algorithm, that is Prime's algorithm, Kruskal algorithm. They are also using to find out the circle. And this disjoint set applications are mostly applicable for circuit design, electrical circuit design, to find out the shortest route. So that is why if you have to avoid this E7, and this is the representation. After that you go for E8. So E8 also if you will go, then where is E8? Here. What you have node you have to go? 6 and 8. Now you tell me 6 is available in which set? This set. 8 is available in which set? This set. So who is the parent of 8? 7. See, 7 is available in this set? No. So what you have to do? You have to combine it, or you have to union it. Union means one parent will be the another parent's child. That means 7 and 8 rank is less, so you have to include here 7 and here 8. So this will be your final graphical representation of disjoint set. So here for the same graph I have represented graphically, and now I will go for the same set to represent it in the form of an array. Now let us check. I will erase all these things. I will show you that the same way how the array representation also possible for the same graph. So let us check that the same graph is same, edges are same, all these are independent set 1, 2, 3, 4, 5, 6, 7, 8. So you can consider it all 1, 2, 3, 4, 5, 6, 7, 8, all are independent. It is saying that when these all are independent, then you should have to represent in the form of an array. Suppose I will erase it. My universal set is 1, 2, 3, 4, 5, 6, 7, 8. Whenever we are representing in the form of an array, so what we should have to keep in our mind, that each and every element we should have to treat as independent first. Whenever each and every element is independent, its parent is itself. So you have to write this is your parent and this is your element, or the nodes you can say. So now you tell me, if each and every node is independent, its parent is itself. That means 1 is 1, 2, 3, 4, 5, 6, 7, 8. Let us check. All these are independent sets. Now one parent is itself. So if its parent is itself, so simply make it -1. That means its parent is itself and it has only 0 child, no child exists, it is only the self node. So then you can represent it in the form of the array like this. Now second case, one by one edge we will consider. So first thing is, if we will consider the edge E1, edge is E1. So what the node we will consider? 1 and 2. So 1 and 2, first you tell me, I told you that all are independent, all are disjoints. So if 1 we will check, 1 is indifferent, 2 is indifferent, we have to go for combining. So whenever we will combine it, we should have to represent it that 1 will be the parent of 2. So if 1 is the parent of 2, the array representation will show you that the 1 has no parent, it is independent, but 2 has parent is 1. So 2 here parent will be 1. And 1 is itself a parent, but how many nodes, how many childs has 1 has? Now including 1 it has 2 nodes, so you have to write it in place of -1, you have to write -2. Now you will go for another E1. What is the edge for E1? E1 is E1 is over, next one is your E2, E2 is your 3 and 4. So both are independent, already I told you. So you can represent it in the form of 3 and 4 by combining or union operation. So whenever you will combine like this, who is the parent of 4? 3. So in place of 4 you can write here parent is 3. and who is the parent of 3? 3 parent is 3 is itself a parent, but how many nodes it has? 2 nodes. So you can write in place of -1 you can write -2. Now next is your E3. What is the nodes? E3, the nodes are 5 and 6. So 5 and 6 you can represent by using union operation. 5 will be the parent, 6 will be the child, and you have to represent the array also. 6 parent is 5, so 6 parent is 5, so you have to write here 5, and 5 parent is itself. 5 have no parent, so 5 have no parent means minus symbol, but total 2 nodes are there, so you can write it -2. Now after E3 you go for E4. E4 is your 7 and 8. So 7 and 8. So you can represent it like 7 is the parent and 8 is the child after union operation, and this also you can represent it. 8 has parent is 7, so you can represent it here 7, and 7 is itself so it has 2 child, you can represent it is 2, not 2 child exactly, it has 2 nodes. So now we have to detect the cycle. Our intention is in the array representation. This is not first one is your graphical representation, second one I am telling about array representation. So in case of array representation, what will be happen like this? After E4 we will go for E5. Let us check for E5. So whenever we will go for E5, what are the nodes are there? The nodes is 2 and 4. You will go for like a tree by using union operation 2 and 4. Now you tell me, whenever we are representing 2 and 4, you should have to represent 4 parent is 2. So 4 parent is earlier, sorry, in E5 E2 is 3 and 4, and E3 is 5 and 6, E4 is 7 and 8, and E5 is your 2 and 4. Okay, 2 and 4. So you should have to check 2 is here and 4 is here. So what you have to do? You have to check that this 2 and 4, you have to again check that who is the parent of this 2 is available in which set. First E5 you check that this 2 and 4 you have gone for union operation. 4 parent is 2 and 2 is available in which set? This set or this set or this set or this set. Those are independent set or not. Then what you have to do? You have to check that E5 So here whenever we are considering age 5, so what we have to do? Now age 5 is our 2 and 4, so we should have to go for the find algorithm. 2 is available in which set? This set, and its parent is 1, and 4 is available in this, its parent is 3, so we should have to go for union operation. Whenever we will go for union operation, what we have to do? Now 1 and 2 and 3 will be the child of 1 and 4 will be here. So after that what we will do? We have to erase this 2. Now we will go for the next age. After E5 we will go for the age that is 6. Age 6, that is 2 and 5. So E6 is our 2 and 5. So we have to check 2 is available in which set? This set. Its parent is 1. And 5 is available in this set, its parent is itself. So these are 2 disjoint sets. So we have to go for union operation. So whenever we will go for union operation, we have to do the same of things, that is 1, 2 and 5 and 6 we will include here, right? After this will be our final, and we have to erase this. Now we will update this array also. 6 parent is 5, 6 parent is 5, 5 parent is 1, so 5 parent is 1, in place of minus 2 you can write 1. Now 4 parent is 3, 4 parent is 3, 3 parent is 1, 3 parent you can write 1. Now and 1 parent in place of minus 2, how many nodes you have to do? 1, 2, 3, 4, 5, 6, total 6, so minus 6. And now 2 parent is 1, the array is updated. Now we will go for the next edge. Next edge is E7. So whenever we will go for E7, you consider the edge is E7, that is 1 and 3. So whenever you will consider E7 1 and 3, what you have to do? Now this 1 is, you have to find out 1 is in which set? This set, and 3 is in which set? This set. So definitely there will be a cycle exist, so you should not have to include this edge. So this edge you should not have to include. After E7, what you have to go for? E8, that is 6 and 8. So E8 whenever you will go, that is 6 and 8. So you have to check 6 is available in which set? This set, and 8 is available in which set? This set. So these both are independent and disjoint. So 8 parent is 7, 7 is also not available here, so that is why both are disjoint. So you have to go for union operation. If union operation will be there, 7 will be the child of 1. So you can go right like this, 7 and 8. So after doing this, this will be your final array representation of, or the final tree, you can say, for final tree of the disjoint set of this graph, this. And here you have to update it. 8 parent is 7, 7 parent is 1, so you have to write 7 parent is 1, 6 parent is 5, 5 parent is 1, 4 parent is 3, 3 parent is 1, 2 parent is 1. So 1 has how many? 1, 2, 3, 4, 5, 6, 7, 8 total. You have to write like this. Now by erasing this, this is your final tree. This is your final tree. Even if by looking this array representation of the disjoint set, you can also calculate or draw the tree. How you will draw the tree? Now here 1 have 8 total, 8 total number of nodes are 8, 1 is the root, right? Because it is in minus, 1 has no parent, so 1 will be the root. So who is the child of 1? Now 2, 3, 5 and 6. So directly you can write the 2, 3, 5 and 6. Next, who is the child of 3? That is 4. Who is the child of 5? That is 6. Sorry, this is 7. And who is the child of 7? That is 8. So from this array you can also calculate. This is the array representation of disjoint set. And the applications of these disjoint sets are, we are detecting the cycle and it is used in finding the minimum spanning tree, and these two algorithms are used, this, that is Prime's algorithm and Kruskal algorithm. Thank you.